Today, I'm going to give a walkthrough of what's needed to be filled out within the Optimizer exercise model. Now, when you first open the Optimizer exercise model, you'll land on this landing page. It's pretty self-explanatory as to the steps and flow of the model. So first, in this exercise, you'll learn how to set up the Optimizer action for the two Optimizer use cases, the network optimization and the production optimization, which you can see a full demo walkthrough of in another video. And then next, you'll learn how to set up the line items that help drive the optimization action. Before beginning, please take a look at the Optimizer documentation guide to get familiar with linear programming and the syntax and how it relates to the Anaplan construct. See, the next step is the review of the Optimizer action. It tells you both how to find it. So to view it, simply go to the Settings, the Actions tab, and under New Actions, you will have the Optimizer option. This is provisioned at the customer level, but you'll see that when you open up the Optimizer action, you will have the button text, the problem, is it linear programming or feasibility, the objective, what you're ultimately trying to what the ultimate objective is of the optimizer. Is it to minimize or maximize a certain result? And again, you can map that to a specific line item within the model. The variables, so the ultimate output of the optimizer, and these variables can be an integer, real, or binary amounts. And then the constraints. So what are the constraints within the model? And again, you can add as many of these as possible, and you link them to a Boolean formatted line item within the model. Going back, after that, it gives you a brief kind of context into the three types of components within the optimizer that I just went through, the objectives, variables, and constraints. And now, after you've gotten familiar with that optimizer action, we can start one of the exercises. So I'm going to start the network optimization exercise. First, we're going to be going into the input data within the use case. As you can see here, this is the supply network optimization use case, which is I have a demand at the store level by month, by SKU, and I need to fulfill that demand with my DCs. So I have DCs that fulfill my store demand, as well as then plants before that fulfill those DCs. So again, we have plants that send the product to the DCs and DCs that send that product to the stores. So here we have all the levers that you can pull within the model to then manipulate your optimization result. We have the plant to DC transportation cost by unit, DC to store transportation cost by unit, plant cost by unit, plant holding cost by unit, DC holding cost by unit, DC fixed costs, as well as DC and plant capacity. And these are levers that you can pull to manipulate your optimization result. There's no need to fill out any formulas within here. Next, we'll go to the constraints. Now this is ultimately where you will want to fill out the formulas. So in this exercise, we have in the instructions given you what the formula should look like. So here it says shipments from DCs to stores, which is a variable. So the output of the optimizer is equal to the SKU store demand, which is the input data, or in the input data module. And as you can see in the parentheses, we have it marked variable and input data to pertain to the exact module that these line items are within. So I will do this first one with you. So as you can see, we've opened up the network optimization constraints module, and here's this demand line item. Please take account that these line items must be Boolean formatted and the summary must be set to all. Also take note of the dimensionality of these line items, as that is key to getting the result from the optimizer that you want. So first, I'm going to activate the optimizer, or activate the demand constraint line item. Go back to the Constraints Dashboard to see exactly what's needed. So shipments from DCs to stores, which is a variable. So we're going to go to the variable. And you can see we have DC shipments as a line item. go back here, is equal to the SKU store demand. So is equal to the SKU store demand, which is in the input data. And now I'm going to click enter, and as you can see, the formula is as simple as that. The DC shipments is equal to the SKU store demand. And now you must fill this out for each of the other constraints within this model. So if I go back to the dashboard, you can see that that one is filled out. And if you go down, we give you the answers in plain speak for what the line item formulas should be. You just must put that or connect those within the different modules within the model or the exercise. So as you can please see, plant shipments, which is in the variables module, is less than or equal to plant capacities, which is in the input data. So once this is filled out for all of the constraints, we can get to the variables and objectives. And as you can see here, we have this objective module. So ultimately what we're trying to minimize within the model is total cost. So you can see here, here's our objective function. And we must go into the module itself and fill out the formulas for each of the line items. So the first one, again, I will do one for you, is the plant shipment transportation cost. So I'm going to click on this to activate the toolbar. Go to the variable, plant shipments, and that's going to be multiplied by the input data, plant to DC transportation costs, because we're ultimately shipping those plants to the DCs. Clicking enter. Now each of these line items, the formula is going to be a variable or an output of the optimizer multiplied by one of the input data or variable costs. So again, the line items are DC shipment transportation costs, plant production costs, DC handling costs, fixed costs, and then total cost, which is going to be ultimately what you're trying to minimize while running the optimizer, that objective line item. That's going to be the sum of all 5 of these line items. So, as you can see here, there's nothing then needed for the variables. The only thing that needs to be filled out is the constraints and objectives modules. After those are done, simply go to the actions, fill out, create a new optimizer action called Supply Network Optimizer. Linear programming, what you're ultimately trying to minimize, and then map it to that specific line item, skin, objectives, total costs, the variables or the output of the optimizer. So the first one is going to be shipments, and the next one is going to be DC shipments. Again, put zeros as a minimum bound for these, as you cannot ship negative items. And then you have constraints. So network solver constraints are going to be demand, plant capacity, DC capacity, as well as DC plant balancing. So these are the 4 constraints, and you can see these are all coming from the same module, network solver constraints. The variables are all coming from the same module, network solver variables, and the objective is clearly coming from the module, network solver objective. After that action is created, we can click OK here. And you can see the supply network optimizer action is now sitting within here. Now all you need to do is simply add it within the process. Click OK. Go to the network optimization dashboard and click Run Network Optimizer. And this will then run that optimizer. And if you've done everything correctly, you will get the green check mark, and your ultimate output of the optimizer will be within these 2 modules here below. Now that is the first optimizer exercise within this model. The second one is production optimization. And as you can see, the landing page for this is very, very similar to the other optimizer use case within this model. So let's again go to the input data. And what this optimizer use case is doing is we're seeing, hey, which SKU should be produced on which line based off of the cost per piece that it takes to produce that SKU, the cost per labor hour per line, the demand by SKU, the capacity hours per line, as well as the run rate, or the units that you can create per hour, and then the compatible SKU line, or which SKU can be produced on which line. So again, nothing that's needed to be filled out within this dashboard. All it is levers that you can pull to manipulate your optimizer result. Next, I'm going to go to the Constraint Dashboard. And again, this is where you will need to fill out the formulas for the specific line items. Again, just like the other use case, we give you the formula that should be within the line item and where that line item is coming from. So again, the compatible line quantity, which is a variable, needs to be equal to the demand, which is an input data. So again, I'm going to do this first one for you. So again, let's click on this first demand. And again, you'll notice that this is a Boolean formatted line item. Summary is set to all. And notice the dimensionality of these line items, as the different dimensionality would manipulate or change your optimizer result. So I'm going to click on the demand line item, activate that formula bar to get the green check over here. Go back to the Constraints Dashboard. See that this is compatible line quantity, which is a variable. So go to the variables and click on compatible line quantity. Needs to be equal to, go back to the constraints, demand, which is in the input data. Go here, click on demand. Simply click enter. Again, this is a pretty plain syntax when it comes to linear programming. This line item must equal this line item, or this line item is less than or equal to this line item. Let's go back to the constraints. So I've done that first one for you, and we've clearly labeled what the other two constraints for this use case should be. We have production hours, which is a variable, must be less than or equal to production line capacity hours. And then a linkage constraint that says production quantity, the output of the optimizer, minus production hours times the run rate, which is ultimately then turning that back into production quantity, must be equal to 0. So we are basically balancing the production quantity to the production hours here. Lastly, let's go back to the variables and objectives dashboard. As you can see, the objective again for this one is we're ultimately trying to minimize the total SKUs cost based off the production costs and the labor costs. And we must fill in the formulas for these three line items. So let's go here. Again, we don't give you too much of the answer for these three line items, but it's always going to be a variable or an output of the optimizer multiplied by one of the input data line items, which is ultimately a variable cost. The first one is production cost. So let's go to the variables. And this is going to be production quantity times, let's go to the input data. And you can see here, we have the cost per piece. So we've done that one for you. The next one you're going to do is labor cost, and then the total SKU cost, which is ultimately going to be production cost plus labor cost. And this is going to be what you map your objective to when creating the optimizer action. So again, after those three line items are completed, let's go back to the actions. We're going to create another new action, optimizer, production optimization. Again, this is a linear programming problem. We're going to minimize the objective, which is this total SKU costs. We have a variable, production quantity, and a variable, production hours. Those are our two variables. Again, we're going to put a minimum on the quantity in hours of 0, as you cannot create or work for negative hours. And then we have the constraints. So production solver, constraints are that demand constraint, that production line capacity constraint, and that production hours linkage. Okay. And we're going to go to the optimizer process, map that action to the process, click OK. Go back to the dashboard. and run the optimizer result. And if you've done it correctly, you should get the green check mark, and the variables should be the ultimate output of the optimizer. That is a run-through of what needs to be done with the optimization exercises. To see the finished result, please watch the optimizer use cases exercise video to see the full run-through of the optimizer results. Thank you.